Okay, so question number 2, this is an usual question. A rubber bug of mass 65 grams. Mass is given that is attached to the end of a 60 centimeter string of negligible mass. L is given and it moves at a constant speed of velocity 2.7 meter per second in a horizontal circle, which means what? It is moving like this over here. Okay, and this length is 60 centimeter here, 60 centimeter here. Mass is the object is over here. Mass is given by 65 grams over here. Okay, determine the centripetal acceleration of the rubber band. So what do we need? Centripetal acceleration. A is equal to V square divided by R. What is V? V. What's the value of V? 2.7 square. 2.7 square divided by what's the value of R? 60 centimeter. This is 0.6 meter. So let us calculate this value. This will be 2.7 square. 2.7 square divided by 0.6 will be 12.15. Will be 12.15. Two significant figures, 2 here, 1 here, 2 here, and so on. So therefore, we'll just write this as 12. What is the unit? The unit is meter per second. This is what is the answer. Calculate the centripetal force on the rubber band. Centripetal force F is equal to m times a. What is mass? Mass is 65 grams. So 65 into 10 to the power of minus 3 multiplied by a, which is 12, which would now be equal to, let's do this. So I do 65 multiplied by 12 will be 780. Will be 780 multiplied by 10 power minus 3, which should be around 0.78 unit is Newton. Okay, then next. The string breaks after it reaches a certain speed. Say the direction which the rubber bung will move immediately after string breaks. So let us say, for example, the rubber bung is moving like this over here, and then this is my radius. So if it breaks here, then what will happen? It will move tangential like this. If it breaks here, it will move like this over here. If it breaks here, it will move like this. If it breaks here, it moves like this. So where does it break? The question is not about where does it break. The question is about, okay, in which direction will it move upon breaking? It will move tangential to the path. So don't write the diagram, but we need the actual answer. Write this as tangential to the circular orbit. That's what you can write. Okay. An identical bung on a string of mass rotates in a vertical circle. Okay. Vertical circle like this. See, horizontal circle is this one. Vertical is this one. Right? Then, by considering the forces acting on the bung, outline at which point in the circle is the string most likely to break. See, it can break anywhere over here, but depends upon the velocity. But if it breaks, then definitely it will be at this point. Why it is at this point? Because tension is maximum here, right? So there is an mg. If you want to know the diagram here, or if you want to know the equation behind it, you can write like this. P is acting like this, mg is acting like this. mv square will always act towards the center. I can now write P minus mg is equal to mv square by r. P is equal to mg plus mv square by r. So which means this value of tension is maximum only at this point. The rest of the points is lesser. Okay. So if at all, if the tension exceeds the breaking strength, okay, the pulling force exceeds the breaking strength, definitely it will break over here, and this is what can happen. Okay. I think we have come to an end to this particular question. Let us move on and see the next question in the next video. Thank you.